My name is Olga Maciaszek-Sharma, and I will tell you a bit about creating and testing REST contracts. So, first I will do a short introduction. Then I will talk a bit about the background. So the circumstances upon which the requirements were formed and why and how this tool was created. And then I will talk a bit about the solution itself, how to use it, how it works. So I'm also keen to take your questions, but we do not have time now. So during the break, if you want to ask any questions or see a demo, then you can come up. So Accurest is a consumer-driven contracts verifier. It takes on easy-to-write scripts, which are written in Groovy DSL. Then it works out of the box with Gradle. It's a Gradle plugin. And it automatically generates both YAML stubs and Spock or JUnit tests. So it's simple to use and develop and requires only a minimal setup. When it comes to the tech stack, it's a Gradle plugin, it's written in Groovy, and it's fully ready to support anything written in Java. And when it comes to testing, it can be tested in a standalone, it can support testing in a standalone application mode, mock MVC, and now also JAX-RS. Also, there are some of our contributors who would like to make it available for Maven, so it might happen. So, how was it created and where did the requirements come from? So, when we were working in a company, and that had a big monolith legacy system, so all the functionalities were in a single logical executable, and it had a considerable level of technical depth and also a considerable level of entanglement when it comes to the business processes, but also to the modules and dependencies. So the idea was, so the problem was that the process of the development was very lengthy and costly. And it took long testing time, and also the deployment took a lot of time just for this, anything new to go through the pipeline. It was difficult to develop because anything that you changed in any module could actually result in a bug in a different module. Then it took a lot of time to build, and it took a lot of time to test in the pipeline. So it was long and difficult to use. So then the idea was to switch to microservices, where you have, instead of this one big executable, you have many smaller services. And this would also affect the way the teams work. So each team would be responsible for one service or more, and the services would communicate primarily via REST. And this posed a lot of new issues and challenges, and my colleagues wrote many different tools to support them and to make things work. But now I'm only going to talk about the issues related to testing and modifying the REST contracts, because that's what led to the creation of Accurest. So there were two zones that we should consider here. First one was creating and modifying the REST contracts, and the second one was testing a system that was microservice-based. So when it comes to creating and modifying REST contracts, there was a big change, because at first there was one server that had a very limited amount of clients. Now we were supposed to switch to a situation where there were many services, each one of them could be a client at the same time being a server, and all of them would communicate with each other, and then the contracts would change a lot more often. And also, as there could be many clients using this, each of other services, it would be possible that the requirements for the endpoints and for the REST communication would clash. Also, as they would change more often, we didn't want a situation when the teams didn't know about the changes. So, because of this, it was required that the teams should get a quick information about any REST contracts that have changed. And this has brought the people working on it to the first requirement that the contracts, the REST contracts, should be consumer-driven. so that the clients of the application should actually define and suggest the changes and the REST communication. And the second requirement was that all the consumers needed to be notified when any of the contracts has changed. And then when it comes to testing these microservice-based systems, there were also new challenges. So the testing team was used to end-to-end tests that were written for the monolith. And there were probably too many of them. The execution was probably too slow. And also, in many cases, same code was being executed again and again during those tests. However, they were quite comprehensive. They verified the borders, and especially the testing team had the feeling that the safety was improved through those tests. So the way it worked was that there was one big pipeline. The main application, along with some limited collaborators, was deployed there. And then the tests were run in the test environment. It would go to stage and then to production. And when it came to microservices, that approach was difficult to maintain. So there were many ideas in place. The first idea was to just continue with one pipeline and just deploy all of the services through that one pipeline, have them all tested together in the test environment, then together and passed to stage, and a new version of each one of them deployed to production at the same time. However, that would not really make sense, because the whole point of having microservices was to make the services independent of each other. So we didn't want the test or the deployment to be dependent, and we wanted to make it faster. And if we had that approach, that would be not productive at all. So the other idea was to have one pipeline per service. So only one service could be deployed through that pipeline. However, each time all of the collaborators would be deployed to the testing environment, and the tests would be done using all the necessary collaborators, and then the deployment would only be for one service. However, making that work would be extremely costly when it comes to the infrastructure and when it comes to preparing all those environments and then managing the tests and the deployment. So the third idea was to have stubs collaborators. And this is used a lot. We all know stubs. But there was an issue of having tests instead of normal end-to-end tests that use stubs. Because what happens with stubs is that they get corroded. So they require normally a human input, somebody who would verify that anything has changed on the server and would adjust the stubs to actually mirror what has happened on the server. And that's why they were not really safe. So it would be difficult from an organizational point of view as well. Because what would we do? We could have somebody informing other teams that something has changed, somebody sending emails. It would be difficult. Probably at any point we would have a situation when the server would have changed without changing the stubs. The test would pass against the stubs again, and then the test of the same service would not pass against the real server, and we would only know this on production. So when it comes to the requirements from the testing point of view for Accurest, it was that we wanted to have stubs, but at any point we wanted to be sure that the stubs were actually working the same as the server would work. So for the same request, we would get the same response that the server would actually give us. So like this, we have come to the entire set of requirements for Accurest. And now I'm going to show you more or less how the process works. So I will use a lot of the client-server terms here. And as I've told you, as we had microservices, any service could be at the same time a client and a server. But while talking about any interaction at one time, I will always refer to the service that has the REST API as the server and the one that sends requests as the client. And yeah, so how Accurest works. We have scripts that I will shortly show you. They are easy Groovy-based scripts. And the client service team can submit a pull request with the new version of the script, of the new script, to the server team. Then the server team can accept this PR, and the same script will be used to generate both wiremock stubs and tests for the server. And then also the new version of the server will be published along with the new version of the stubs, only when all the tests have passed. So this is what it would look like on a diagram. First, the client team is submitting a pull request with the DSL scripts to the server team. And this is what Accurest DSL script looks like. So as you can see, it's quite similar to a JSON file, but it's arguably more readable and easier to work with. So it will have a request part and a response part. And then we will have all the things that we expect when we define a REST interaction. So we'll have a method, a URL, a body. Of course, body is not obligatory in the request, but you can add it if you want. Any number of headers that you might need. And then in the response, we'll have the status, the body as well, and the headers. And now the server team has accepted this pull request, has merged it, and they have the scripts. So they can generate stubs. Now, the stubs that we are using for now are wiremock stubs, and wiremock allows you to actually have an actual HTTP server that mounts all this stub on itself, and any test that you run will be run against those stubs. So it will just behave like a regular HTTP server and serving you the contents of the stubs. So this is the stub that we get from the script. The stub is completely automatically generated. That's what Accurest does for us. You don't need to do anything. You just get it. And of course, you have the request part. And same as in the DSL, you had a URL. Here you will have it as well. We'll have the method, and then the stub will have the same method. The body part will be turned into body patterns, and for the request, we'll be validating if it matches a certain JSON path. And then, of course, we'll have headers, and we will verify them using equal to. And then in the response part, we'll have the status that we gave. Then we'll verify the body and the headers. OK, so now we have the stubs. But the thing is that Accurest will not only generate the stubs. If you will run a great, clean build with a well-configured Accurest, what you will get is also the tests. So apart from the stubs, you will have automatically generated tests like this one. So these tests will verify if actually your server behaves exactly as the stubs describe it. And you will get them each time. So there is no situation where you can just make stubs and have no tests that will verify them. It will always go together. And as you can see, in this test, we're using REST assured, and we're also using a JSON assert library for verifying JSONs. So if you don't know from where some methods are coming, they will be probably from any of these two libraries. And coming back to the DSL script, here we had our body and our headers. So in the automatically generated tests, it will be modified to a request from a REST assured in this way. And then the information about the method and about the URL will be used to make the actual call. And then we'll be able to verify if the status that we get is the same that we expect, if we have the right headers, and also for each and every part of the body, we'll verify if this element that we expect is present in the response. So in order to make it work, we will have to provide a base test class. A base test class will be a class where you will set up the way the application will work while tested. So the easiest way is probably using mock MVC, and then you can just use rest assured mock MVC as in the first part. However, you can also use Spring web integration test from Spring, and then you can test it as a standalone app. That's something that you can configure in your Gradle file in the Accurest part. And this will, in the case of Spock, this will extend specification. OK, so once you have set it up, you have the stubs, you have the test, you have implemented the changes, so your tests are passing. You need to make these stubs published and deployed to any Nexus or any other platform together with your new version of the server. It's very important for Accurest to work to make it dependent on each other. So when you set up in your Gradle the publish task, you need to set up the publish of the stubs together with the publishing of the new version of your application. OK, one very important thing that Accurest supports is regular expressions, because as most of you know, usually when we are making any kind of tests, we would only want to specify that any value is in a certain range. For example, we are sending a request for a client ID, and we don't always want to specify the same ID. So any ID that will meet a certain regular expression should be fine for us. And this is how we can put it in Accurest. If you just put regex, your stub will contain a regular expression matching verification. However, the test needs to have a certain value. You cannot really test using a regular expression. You need to input some data. So in the test part, we specify any value. And it allows us to get the following stub and test. So here we have a regular expression, while here we have a value. That was like the first requirement that we had when Accurest was released, and we started using it. It was not possible to use it because it lagged that, but that was quickly fixed, and I think it's very important. So there are also some other functionalities, such as query parameters are supported in the script. Then also optional fields are supported, and also executing custom methods on the server side. So instead of just giving a plain value, like you had an ID 1, 2, 3, 4, you can just put in the script, execute a method, and then use any method that you will define in the base test class to compute that value. And it also deals well with all the nested elements and that are usually present in JSONs and in responses. So if you even have a body with nested levels, the Accurest will be able to verify it fine in the tests. OK, so now I would like to tell you about possible issues that we've discovered. So Accurest was made for working with microservices, and it has proved to be really fine there. However, as the users, we were very enthusiastic with it, and we wanted to make it work in a bigger system. And there we have found a number of issues. So basically, what Accurest allows you to do now is only define one base test class. And what happens then is that if you want to do some, in a case of a complex system, some mocking or stubbing to support the test, because you don't want to run the system each time for those tests, you have to have it all in the same hierarchy of this base test class, and it becomes complex. So that was one issue. And also for projects that have already a complicated Gradle setup and many modules, it could be a bit complex to set it up with Accurest. It is definitely possible, but it can take some time. Another thing it is Accurest is a young solution, so we have the version 1.0 now, and it keeps changing, and there can be some issues due to this. About a year old, but also the development team is working quite efficiently on solving any bugs. So this can be a drawback, but this can be also an advantage. So I would like to show you a small demo. Okay. So first, what I would like to show you is that here we have a sample project. And in this sample project, we have a controller that is supposed to implement have a functionality. But as you can see now, it's commented out. It will not work. And it will not give the right response if the amount is too high. And then we have a client that uses that service. And in the test of that client, we assume that there's a wiremark running with the appropriate stubs for that service. And here, we have a directory where, according to the Accurest setup in this project, we should have our Accurest mappings. They're not present, so we don't have any stubs and we don't have any tests. And now, if we run Gradle build, we assume that the test should fail because there should be no stubs mounted on the wiremark instance. Okay, so the tests have failed as we have expected. So now, let's put some scripts there. And we have the scripts similar to those that we have seen during the presentations. So now we will expect here to get 200 status and the fraud check status reply fraud whenever we pass a high amount, like the one we have here. And we will expect to get the OK result and rejection reason null whenever we have a lower amount, like the one here. And as you can see in the build, here we will expect to have our tests, and here we will expect to have our stubs. For now, there's nothing here. So when we run it, okay, when we run it, and we will get our mappings. Oh, yeah. They're exactly as we expect them to be. And we will get our tests. And these tests actually should fail, and they have failed, because a part of the functionality was commented out. So if you go to this controller, and you uncomment it, and you run it, then now we expect to have exactly the same tests, the same stubs, the stubs mounted against wiremark, and the tests to pass. Let's see what happens. Has happened. So, thank you, the demo gods. Nearly worked. Okay, if you have any questions, you can ask them now, because I think we have like 2 minutes remaining. And if not, then you can catch me on later, and I can also give you the demo code or show you any scripts that you might be interested in implementing. Yeah?
I have a question. Last time I looked at
I think there is, definitely there is some documentation now in the wiki. If you go to GitHub, there are examples of both Accurest scripts and the tests. So you can find it there. Also, well, I know it's not perfect, but a very good way of documenting are the tests that we have in the DSL project, because we have really tried to test it very well. There is not a single use case that doesn't have a unit test, and the tests are like this, that you pass the script and then you see what stub or what test you expect. However, definitely we will also work on adding more documentation.
Allegro has contributed some documentation wiki, so you should check it out.
Okay.
Okay, yeah, so if you have any more questions, then please contact me in the break.